Hello, this is Mrs. Edwards, and I am doing problem 775 to 781, review and preview out of the CCG book. When we look at 775, it asks us to identify each pair of triangles below and whether it is congruent or not. Remember that the diagrams may not be drawn to scale, and we must always justify our conclusions. So looking at example A, when we look at these two triangles, we can see that this side is congruent to this side. So we can state that the sides with one hash mark are congruent because it was given. We then look at our picture and we see these sides with two hash marks are also congruent because that is given. Then looking at both of these triangles, the shared side, we say, is congruent based upon the reflexive property. So we can say that side 3 is congruent to side 3 because of the reflexive property. Which then leads to prove that if we have three sides that are congruent, our triangles are congruent based on the side congruency theorem. Looking at example B, we have a triangle that has a length of 5 and a length of 5 in our second triangle. And then we see this side here is a length of 4, which doesn't appear to match with this 4 on this side. So we do not have enough information to conclude whether the triangles are congruent. Looking at example C, we first can look at these angles right here that have one tick mark, and they stated, so the angle with one tick mark is congruent to the angle with one tick mark, and we can say that is because that is what we were given. We can also say that our angle with two tick marks is congruent to our angle with two tick marks because that was also given to us. Then looking at both of our triangles, if you notice this portion of our triangles here, we call that a shared side. So we can say that that is congruent, and we notice that the piece of this bottom one is 3 and the piece of this bottom one was 3. So we can say that these two triangles are congruent based on the angle side angle congruency theorem. And we want to use the side with two tick marks was congruent to the side with two tick marks based on the reflexive property. So all of those lead us to, all three of those together lead us to the triangles being congruent. Looking at letter D, we can see that this hypotenuse in both of these triangles are congruent based on the tick marks. So side with one tick mark is congruent to the side with one tick mark. That was given. We then can tell that the shared side is congruent based upon the reflexive property. So the shared side, which I'll represent with two tick marks, which then can lead us to the fact that these two triangles are congruent based upon the hypotenuse leg congruency theorem. So in problem 7-76, it said for either part A, C, or D of problem 775, create a flowchart to prove your conclusions. So you can see that I already created those flowcharts. It's really important that you always start with your given information and include a reason or a justification for every single bubble. So you can see below each bubble that I concluded or included, my justification. Problem 777. In the diagram below, angle DCA is referred to as an exterior angle of triangle ABC because it lies outside of the triangle and is formed by extending a side of the triangle. So problem A says, if the measure of angle CAB is 46 degrees, so you want to go ahead and label your picture. The measure of angle ABC is 37 degrees. What is the measure of angle DCA? So in order to find the measure of DCA, we first need to find the measure of angle ACB. So to find the measure of angle ACB, we can take 180, subtract 37 and 46 degrees, which tells us that this angle is 97 degrees because we know that all the angles in our triangle add up to 180. We then know that a straight line is equal to 180 degrees as well, so we can take 180 degrees minus 97 degrees, which will tell us that angle DCA is equal to 83 degrees. Looking at problem B, we want to first label our diagram with the information they gave us. They said the measure of angle DCA is 135 degrees, so DCA equals 135 degrees. ABC is equal to 43 degrees. What is angle CAB? So the first thing that we need to find is angle ACB, which is 180 minus 135, gives us an angle measurement of 45 degrees. When we look back at angle A, we know a triangle adds to 180 degrees, so we subtract out the 43 degrees for angle ABC. We also subtract out the 45 degrees for angle ACB, which will tell us that angle CAB is equal to 92 degrees. Also make sure you put an M in front of your angle on both of these examples so that we know we're talking about the measure of the angle being whatever degrees it is. Tramika, in problem 778, Tramika wants to find the area of an isosceles triangle below. She decides to start by drawing a height from the vertex A to side B as shown below. So she drew this height in. Will the two smaller triangles be congruent? In other words, is triangle ABD congruent to triangle ACD? Why or why not? So what is the measure of angle DAB? So when we look at DAB, we can take 36 degrees and divide that by 2, which tells us that the measure of angle DAB would equal 18 degrees. They then asked, what is the measure of BD? Well, if we look at this line segment right here, we know that it is half of 8. So 8 divided by 2 would tell us that line segment BD is equal to 4. It then asks us to find AD. So looking at the measure of 18 degrees, if we are looking to solve for the length of AD, I remember that the tangent equals opposite over adjacent, which I know the tangent of 18 degrees should equal my opposite side, which is 4, over my adjacent side, which is x. Using inverse operations, and when I say x, I'm talking about line segment AD, I multiply both sides by x. The inverse of multiplication is division. So if I divide both sides by the tangent of 18, I create one giant 1. Whatever you do to one side, you must do to the other. So AD equals 4 divided by the tangent of 18, which is approximately 12.3 units. So again, we want to state that line segment AD is about 12.3 units. It then asked us to find the area of triangle ABC. So when we find the area of a triangle is equal to 1/2 times its base times its height. So if we know that its base is 8, and we now know that its height is approximately 12.3, and we type this into our calculator, we can say that the area of triangle ABC is about 49.2 units squared. Problem 779 says on graph paper, graph the quadrilateral ABCD if A is 0, 0, so you can see I've plotted A there. B is 6, 0. So if we go over 6 and don't rise any, I plot that there. Notice I'm counting by 2 on both of my scales. C is 8, 0, 8, 6, excuse me. And D is 2, 6. So over 2 up 6, and I can plot my D. What is the best name for ABCD? It is a parallelogram. And I know that because my opposite sides have the same slopes, which implies that they are in fact parallel. You can look at your opposite sides by doing your slope triangles, and you can see that they rise 6, run 2, so 6 over 2, 6 over 2. If you look at your slope triangles, you can then see that line DC and line AB have a slope of 0, so those slopes are the same as well, which denotes parallel sides. Find the equation of the lines containing each diagonal, that is, find the equation of line AC and line segment BD. So when we look at line segment AC, we want to see what the y-intercept is. So y equals mx plus b, which looking at our line, we can tell that our y-intercept is 0. And then if we look at our slope triangle, we rise 6, we run 2, 4, 6, 8. So if we write 6 over 8 for our slope, that reduces to 3/4. X plus 0 is the equation of line for line segment AC. When we look at line segment BD. If we draw our line using a ruler, it appears that our y-intercept is 9. But we can also use 2 points, which we know our two ordered pairs are 2, 6, and 6, 0. We can first find our slope by using change in y, 6 minus 0 over change in x, which gives us a slope of negative 6/4, which reduces to negative 3/2. When we have a point or an xy coordinate and a slope, we can plug it into y equals mx plus b. So I replace my y with the y value of my ordered pair, replace my x with the x value of my ordered pair, and I put it over 1 so that I can properly multiply my fractions straight across. 0 is equal to negative 18 over 2, which reduces to negative 9. When I use my inverse operations and add my 9 to the other side, I get my b, which you can see is your y-intercept. Then to write the equation of line segment BD, you have y is equal to our slope, which we found using our 2 points, is negative 3/2 x plus 9. Remember, there's a few ways to do that, but algebraically, this is the way to go. Problem 7-80. It is often useful to estimate the value of a square root to determine if your answer is reasonable. So we need to remember that when we are estimating the value of a square root, we want to pay really close attention to our perfect squares. And when we talk about perfect squares, we're talking about 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. Those are our perfect squares. So what would be a reasonable estimate of the square root of 68? Explain our reasoning. After you have made an estimate, check your estimation with a calculator. So when I look at the square root of 68, I think of the square root of 64 as being equal to 8. If I'm looking at the square root of 68, it should be a little bit greater than 8 because it's slightly bigger, so I'm going to guess approximately 8.3. When you plug that into your calculator will tell you it is approximately 8.24. So you can see that my guesstimate is very close using that perfect square that I knew. We're going to repeat this process to estimate the values below. So B1 says the square root of 5. Well, I know the square root of 4 is equal to 2, so I am going to guesstimate that this is close to 2, and my calculator tells me 2.2. B number 2, looking at the square root of 85, I know that the square root of 81 is 9. So I'm going to say slightly larger than 9, and in fact, when you plug it into your calculator, you get about 9.2. When we look at the square root of 50, the square root of 49 is very close, which is 7. So when you type this into your calculator, 7.1 is very close. When you look at the square root of 22, the square root of 16 comes to mind, which is 4, and the square root of 25 comes to mind, which is 5. So I would say 22 leans closer to the square root of 25. So when you type this into your calculator, you get approximately 4.7. In problem 7-81, for each diagram below, they ask us to solve for x and to show all of our work. So looking at letter A, I know that if these two sides of my triangle are congruent, that tells me I'm working with an isosceles triangle, which means the base angles of my of my triangle are also congruent. So I'm going to take 180 degrees and subtract 52 degrees from it, which is going to give me 128 degrees. I then know that these two angles are congruent, so I divide the 128 by 2, which tells me that angle X is approximately 64 degrees. Looking at example B, I have a straight line, and I know that a straight line is equal to 180 degrees, so I can take 4x minus 3 plus 3x plus 1, set it equal to 180 degrees. I'm going to combine my like terms, so 4x plus 3x gives me 7x, negative 3 plus 1 gives me negative 2. I'm going to use my inverse operation, so the inverse of subtracting 2 is adding, so I have 7x is equal to 182. The inverse of multiplication is division, so I get x is equal to 26 degrees. So be very careful on tests like the ACT may ask you for specific angle measures, and you would have to plug that x back in. Before this problem, they just asked us to solve for x. In example C, if we are going to solve for x, we have two angle measures and we have two side measures. So what should come to mind is the law of sines, but we got to make sure that we have the angle measures directly across from the sides we are given. So this 8 is directly across from this angle, which we need to find. So 180 minus 77 minus 31 will tell us that this angle is in fact 72 degrees. We now can set up our proportions. So we can set up the sine of 72 degrees over our side length, which is 8, is equal to the sine of 77 degrees over the side length of x. We then are going to use inverse operations, so the inverse of division is multiplying by 8. So if we have 8 over 8, this equals 1 whole. So on the left-hand side, we have the sine of 72 degrees is equal to 8 times the sine of 77 degrees over x. The inverse of dividing is multiplying. Again, we have x over x. So x times the sine of 72 is equal to 8 times the sine of 77. The inverse of multiplication is division. We have one big whole. Whatever we do to one side, we must do to the other. When we type this into our calculator using all of the appropriate parentheses, we get x is about 8.2. When we're looking at example D, we have two parallel lines cut by a transversal. So the angles that we are working with are alternate exterior angles, which if we have two parallel lines cut by a transversal, we know that those two angles are equal. So we can set 5x plus 6 equal to 2x plus 21, use our inverse operations. So we get 3x is equal to 15. The inverse of multiplication is division, and we get x is equal to approximately 5 degrees.